Hi everyone, we're going to be looking at radius and tangent meeting again at that 90-degree angle like we talked about previously, but in this key skill, the questions are going to have a different spin. We're going to have more of a trigonometry spin. Let's jump into our first question. The circle C has a center A and a radius R. We've been told that this is the equation for the circle C. X minus 5 squared plus y plus 2 squared equals 25. So straight away we can get a little diagram growing because we know that the center will be at 5 minus 2. So here we go, 5 minus 2. And the radius will be 5. So 5 above, 1, 2, 3, 4, 5. 5 to the side, 1, 2, 3, 4, 5. Other side 5, 1, 2, 3, 4, 5. Put little crosses. And below, 1, 2, 3, 4, 5. So this is what our circle C will look like. Okay, you can label it. And like I said to you previously, it's a good idea to pencil in 5 minus 2, the center. So that's the circle on our diagram. They haven't told us to do a diagram. I find it's much clearer and you'll be able to visualize it much better if you can see in your mind the diagram, and it only takes an extra couple of minutes and you'll save that time by doing the calculation much faster. So we've been told that it has a tangent at the point B. Now we don't know what B is at this moment, but we do know that the tangent L passes through the point 0, 8. So we're going to mark that here. C is 0, 8. Okay, so that will be 0, 8 here. That's point C. So we know that the line's going to come through here and it's going to hit, it's going to hit the circle at exactly one point, and that point where the tangent intersects with the circle we called point B. Now we don't know what the coordinates of B are at this moment, but we do know that a radius and a tangent will always intersect at 90 degrees. Okay, so that there will be a right angle. We went through the proof of that previously. We've been asked to find the size of the angle A to C to B. So A to C to B. We need this angle there. I'm going to join A to C to form a triangle. Okay, so if you can see, I'm going to shade it in here. This here is our right angle triangle. And this is the point 0, 8. Now, if you think back to what we know about the line, we can use these two coordinates here and the formula for the distance between 2 points to calculate this distance from A to C. The distance from A to B, we already know it because from A to B, it's from the center to the circumference, so it must be radius. So this distance is going to be 5 because the radius of this particular circle is 5. So the length from the center to the circumference needs to be 5. Now we're going to use SOHCAHTOA, we're going to use trigonometry to find this angle ACB, but when we use trigonometry we need two sides. We've only currently got one side, so that's where the formula for the distance between 2 points is going to help us out. So let's use our 2 points as 0, 8, which can be x1, y1, and 5 minus 2, which are going to be x2 and y2. I always harp on about this, but I always think it's really good to write the formula down every time. So d squared is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, so the distance squared will be, now substitute your numbers on the second line, 5 take away 0 squared plus minus 2 minus 8 squared. So d squared. And you notice like I'm keeping everything in nice neat lines. 5 minus 0 is 5, so that'd be 5 squared. Minus 2 minus 8 will be minus 10, so minus 10 squared. So d squared will be 25 plus 100 d squared will be 125, and d would be the square root of that. If you want, you can take out the 25, going back to what we've learned about surds, and have that as 25 times 5. And the square root of 25 is 5, so that'd be 5 root 5. And again, your calculator will do that for you. So I'm going to add that to my diagram. So this is 5 square root 5. I'm now going to mark in that the angle that I want. So remember, A to C to B. So this will be the angle that I'm missing here. I'm going to call it theta. You can call it x if you prefer. Now, if I label the triangle, opposite the right angle is always going to be hypotenuse. So this will be, let's take a different color. This will be hypotenuse, or hype for short. If you imagine that you are at the angle and you shoot a bullet, then you'd hit the opposite side. So that will be opposite, and that will be adjacent. So the information I've got is hype and opposite. So if I think about my trigonometric ratios, you're choosing between SO, CA, or TOA. You don't have the adjacent, so you can eliminate CA and TOA, and that leaves you left with sine. So we know that sine theta is opposite, which was 5, divided by hypotenuse, which is 5 square root 5. You can cancel down the 5s if you want. And that gives you an acute angle of 26. I'll probably do 2 decimal places here, unless you're specified in the question to do something different. So 26.57, and that's in degrees. So to find the missing angle, we use 2 things. We use the fact that we could calculate one of the distances using the distance between 2 points formula. And then we had a right angle triangle, which we knew was a right angle triangle because of the property of the tangent and the radius intersecting at 90 degrees. And we had 2 lengths, one we got from the radius and one we got from calculating it. And we used our SOHCAHTOA. Let's have a look at question 2. Hence or otherwise find the lengths of B to C. So B to C would be this length here. Now, if you think about it, now we've got a right angle triangle and we've got 2 sides. We've got this side and that side, and we're missing the third side. So whenever you have a right angle triangle and you know 2 sides, but you don't know the third side, you can use Pythagoras' theorem. So in question 2, I'm going to say h squared is equal to a squared plus b squared. Now h we said was 5 square root 5 squared. A, for example, you can label it as A and B. It doesn't really matter which way around you label it, but I like to call the unknown quantity, have that first. So we can put the x here. So A will be x and B will be 5. Okay, so that's my A, that's my B. Equals x squared plus 5 squared. So this is going to be 125. And 5 squared, actually we can work that out already, is going to be 25. And again, if you didn't want to do this in your head, you could just type it into your calculator, 5 square root 5. We already saw this the other way around on the previous question. So we went from d squared 125 to d by taking the square root. So if we do 125, take away 25, that will give us x squared. So that's 100 is x squared. And so we take the square root of 100 to get x. So x must be 10. Remember, in this situation, when you're dealing with length, you don't need to take plus minus because it's impossible that length is negative. So x is 10. And always, I would recommend at each step, keep updating your diagram. So now I'm going to take that out and put in here all the information. We had this was 10, and we had this was 26.57. Okay, in question 3, we're asked to find the area of the triangle ABC. So we want to find the total area of A to B to C, so this triangle here. There are 2 ways to do this. You could use the half AB sine C formula. So you could say a half times 5 square root 5 times 10 times sine of 26.57. Or you could use this property that this is a right angle to help you and use the half base times perpendicular height formula. And I would definitely do that here because it's going to be much easier. So area of a triangle, and again I always write my formula, a half base times height. We had a half, we had the base was 5 and the height was 10. So we can cancel that and that there. We'll have 5 times 5, which is 25 units squared. And that key skill is done. Now remember, you can only use the half base times height formula in the situation where you've got a right angle. If it's any other angle, use the half AB sine C formula. If the half AB sine C formula is a bit rusty for you, go back and check out the videos all about sectors. So that's key skill 6, done and dusted. I think once you put the right angle in and you draw the diagram, it becomes quite a simple question. But if you're just reading the text on its own, it feels quite complicated. So in key skill 7, we're going to be looking at when you have not only one tangent, but 2 tangents. And that's a wrap. I'll see you guys in the next video.